Hello everyone, welcome back. So in this video, we are going to understand the Leetcode problem number 3558, a number of ways to assign is weight 1. So the problem belongs to the graph because it's a undirected tree and having n nodes where it is saying that the level start from the node is from 1 to n and its root start from the node 1. Okay, so basically you have given a kind of tree, but it's a graph. Okay, so tree is a graph and it's represented 2D array as a edges. I'll show you here. If you see the example, we have given 1 and 2 like this. So 1 is connected with the 2, right? Where the edges we have given is u and v, right? So we can say that this is not a tree problem, but this is a graph problem. Okay, so it indicates there is an edge between u and v because that's we can see here, right? If the pair we have given u and v means u is connecting with the v, right? Means like this, we have u is 1 and v is 2, so it's connecting 1 to 2, right? So like that we can say, right? Means the very first we can say is that we have n nodes, right, that levels from 1 to n and rooted as 1. Okay, and we know already how the connection works for the edges, right? So initially all the edges have a weight of 0, right? And you must assign each weight either 1 or 2. So the edges that we have given and the graph that we have given, right, we don't have the weight, but you have to assign the weight either 1 or 2 for the each edge. For each edge means if the two nodes are connecting, there will be edge, and that weight we don't have given, right? Means you have to assign either 1 or 2. Why? Let's understand why. Because we have to find the cost, right? And the cost of the path between any two nodes u and v is the total weight of all the edges in the path. So how will you find the weight, right? You can find the weight, so how will you find the cost? Sorry, okay, not the weight. So how will you find the cost? You will find the cost only based on the weight, right? That is why you have to assign either 1 or 2 for each edges. Okay, so whenever you will find the path between the u and v, means any two nodes in the graph, right? So there will be depth, and that depth is called the weight, right? Means let's suppose from u to v comes, then v to x you are going, right? So that there should be a edges between them, right? So that edges will be counted for the weight, and that weight will be counted for the cost. Like that we can say that. Okay, so select any node x at the maximum depth, right? You have to go to that depth from the root to keep going down until the maximum depth where you have given the tree, right? There you have to go and you have to return the number of ways to assign the edges weight in the path from 1 to x in such a way that you will find the total cost is odd. We don't need the total cost in the even number, we want the odd, right? And that is the logic here works, that we will talk more here. Okay, so it's a 10 to the power 9 plus 7, and we have to take the modulo, so the answer become large, so you can take the modulo and you will return. Okay, so the code all the answer will be accepted, okay, due to the test cases. You have to ignore all the edges not in the path 1 to x. Okay, so let's try to understand let's visualize this problem so you will understand here. Okay, so example 2 is perfect for our understanding, so let's go with the example 2. So let's suppose we have node 1 to 2, right? And then we have 3 to 4 and 3 to 4. So here 4 and 5 having the same depth because it's a maximum depth, right? So as you can see, the max depth is 2 with node 4 and 5 at the same level. So either node can be selected for the processing, either 4 or 5, either of the you can use, right? So if you see here, if we'll take the path from 1 to 4, right? So the edges, let's suppose 1 2 3 is let's suppose we'll take like this one edge and another is this, right? So it's all depends on you how you are choosing the path, right? So let's suppose either you will choose the weight 1 or 2, right? Either 1 to 3 is 1 and 3 to 4 is 2. So you will get the weight 1 plus 2 is 3, right? So either you will get the weight 1 2 or 2 1, right? That will give the cost as a odd, because we have to find the total cost should be odd, not the even. That is why either you will use 1 2 or 2 1, but you cannot use 1 1 or 2 2. Okay, because it will give you the even cost. Got it? And in this way we can say the number of assignment is 2, because we have to take the assignment like this, so we need to find the number of valid assignment 2. Okay, so this is the way we will go and we'll try to understand here, right? Let me show you something. So let's understand the very first thing that we understood, that either we can go from 1 to 3 and then 3 to 4, let's suppose, right? And we can either choose 1 for the odd and 2 for the even, right? Like this we need, right? Means only those two edges matters. For 1 to 3, the very first is this one and the second edge is 3 to 4, right? So each edge can have either the odd or the even, because for the path of length d, let's suppose we have a length d from here to here, right? That is called, let's suppose, d. So for the path of length d, we there are the 2 to the power d total assignment. Okay, assignments, can we say that, right? So exactly half of them we will produce an odd sum, right? If we'll take the half of this, right, that will give you what? It will give 2 to the power d and minus 1, we can say, right? Like that. So this will be the our half of the total assignment, right? Can we see that? So for, if we'll say, okay, for d is greater than equal to 1, if the tree has one node, then d is equal to 0. If tree has 0 node, right, means no edge is there. We have one node, only one node we have, right? But the edges we have is 0. In that case, d is 0, right? Means 2 to the power 0 is equal to 1. Like that we can say. Still we are getting the answer, right? So we'll say, okay, if the d is 0, right, means there is no edge, because there is no edge, right? So we'll provide 2 to the power 0, right? Like this we can say, no edge assignment. So the answer is what we'll say is d equal to 0, right? So the half are the odd, right? So for any path, it contributes either 1 or 2, because 1 contributes the odd parity and 2 provides the even parity, right? Like that we can say that. Okay, so what we want is, we will build the tree adjacency, right? Then we'll run the BFS or DFS. You can turn from the node 1 to the max depth, right? Like you can start from here and you will keep going the depth, right? Like that we can say. So we'll return depth if we will return 0 if depth is equal to 0. Simple. The first condition we have to make like this. We will return in otherwise we will return, like we will take power of 2, we can say, and we'll pass the depth minus 1, and we'll take the mod with 10 to power 9 plus 7, we can say that. This is what we will do. So I'll show you how to implement this type of problem. Okay, so let's go and try to understand the code. So the very first thing that we have given is, right? So edges we have given. So we know that the tree we have is n level tree we have from 1 to n, right? Means edges dot length plus 1 will say, and we'll find the all the number of nodes, right? The number of nodes we will find, right? Edges length plus 1. Okay, then we can build the adjacency list, the graph n plus 1, and we can start from 4 I equal to 1 to I is less than n, and we'll initialize the graph, right? Then from each edges we can get the two nodes u and v, and we know that it's a undirected tree, right? So what you will do, you will just say graph.u and graph.v, right? Graph at u, you will add the v, and graph at v, you will add the u. That is a unidirectional, you can say, or undirected. If direction is not given, it means you have to add u to v and v to u, right? Like that we can say that, right? So for each edges we'll get, and we'll do that. Okay, now it comes with the BFS traversal. So what we do, we will take a visited boolean, right, where we'll mark the tree node so that it will not go in the loop, right? We can say that. So after that we'll create a queue, right? The queue will contain the node and its depth, right? So you need to take it like that, and The very first that the root start from the node 1, so we'll offer 1 and 0. 1 is the node and 0 is the depth, right? Depth is 0 for the one node, right? So this will do. So basically visited will provide visited array will define, then the queue will define, then we'll offer and we'll mark the root node as a true that we have marked. Now comes with the depth. Okay, so we'll define the max depth, and over the loop, right, we'll check if queue is not empty, we'll find queue dot poll, and we'll find all the current node and its depth, right? So this is node and depth we'll find like this, right? And we'll each time we'll track the max depth. What is the max depth on the current node that we are processing? For each node, right, we will find its next node, right? Because we are doing the BFS, right? So what we will do that we can get the next node, and from the next node we'll very first we'll check if it is visited, will not go here. Otherwise we'll first mark that visited, then we'll add into the offer. So we'll start from the next and we'll just do depth plus 1. So each depth we will increase 0 from root node 0, then 1, then 2, and so on. We'll keep going ahead, right? Like that we will do. And you will, this loop will process for all the node until all the node are not visited. So we will mark all of them as a visited, and we have track the max depth. So this loop basically is used for tracking the max depth. Okay, once we are done, right, we know that we have traversed and we are able to find the distance, right? We can say that. So you can say max depth. Okay, so basically if max depth is equal to 0 means it's a single node tree, return the 0, don't do anything. You don't need to do anything, okay, because you have already marked the root node. Let's suppose the very first node, only one node is in the graph, so it's a root node and you have already traversed. It will not go into checking the is visited or not, because it's already visited, so you will not find the next node, right? So you will know that the max depth is 0 and you will return the 0. Now what? Now if you have the max depth, right, if the max depth is there, so you need the mod power. Power is what? 2 to the power max depth minus 1. You will do that you will do, and basically this is the base and this is the expression you will pass, right? So base is 2 and the max depth minus 1 is the expression. So you know how to implement the power of 2, right? So like that we will define it, the mod power. We will pass the base expression. So we'll start the answer from 1. You first check the base mod with the given value. Mod is nothing but the 10 to power 9 plus 7 that we have already defined here, right? 10 to the power 9 plus 7, and that value will be there, right? So this value will you will get the value base, right? And now we'll check the expression is greater than 0. So we'll first check with the condition if equal to 1, you will update the answer, right? Like this. Otherwise you will update the base, you will calculate the expression, and this loop will go until the expression is greater than 0. If it is equal to 0 or less than 0, it will not go. Then you will have to return the answer. So basically this function is the mod power, right, that you need to do. And yeah, so you will, if you have the max depth, something you will get other than the single node value, right, then you will get the max depth and you will return this data. So that's all what I have in this video, guys. So why we have not used the brute force? Because if you apply the brute force, if definitely it will go to the O of n square, and that is not the requirement here. So you use the graph algorithms like BFS, and that's all I have in this video. Thank you so much. If you are learning something new, share with your friends, like, subscribe, and also if you are struggling with the DSA preparation, you can join our online classes, and you can ping us on the WhatsApp, and from there we can explore your journey. That's all I have in this video. Thank you so much, and let's connect in the next video. Thank you. Bye bye.